Good day everyone, my name is Jörg Swart, and as you remember last time we did some similarity with the Euclidean geometry. So today we will be looking at proportion. With our experience from marking the grade 12 examination in the last 2 years, we found that the question 9 in the paper 2 that handles on proportion is the worst answered question. So I want to take some time today and explain to you proportionality so that you can see the difference between proportionality and similarity, and that you can know how to apply the proportion to a triangle. Firstly, we will just run through similarity again, just so that you will know the difference between similarity and proportionality. So two triangles will be similar when the three pairs of corresponding angles are equal, or the corresponding sides are in proportion, or they are divided in the same ratio. Okay. So then if you look at the example given, you will see that they have indicated that angle E will be equal to angle U, because there's only one arc. You see that angle T is equal to angle C because it's got two arcs at both angles. And then if you look, angle A is equal to angle P. Therefore, you've got three pairs of corresponding angles which are equal. And therefore, you can say that these two triangles will be similar. Okay. Then, when triangles are similar, and I will show you this when we do the examples, then there's a specific way in which we can write the proportion or the ratio to which the sides are divided into. But we will get to that in the examples. So, if you look at example 1, they ask us to prove that triangle ABC is similar to triangle EFD. So obviously, the first thing that you will have to notice is to see, are we working with the sides or are we working with the angles that are given? So then you will look and you will see that I've got an angle, and then the third angle is left out. Then we've got in the second triangle, we've again got an angle, and then the third angle are left out. So obviously, you will know that you will not be using the length of the sides to prove that the sides are divided into the same ratio. So we will start with the angles. So firstly, we try and distinguish between which of these angles are equal and whether it will be necessary for us to determine the size of angle C and angle D. So let's start writing the example. So first thing, we look at what was given. So we see that angle A is equal to angle E. So we will write angle A is equal to angle E. And the reason what we give there is given. Then we go to the next angle and we see that angle B is equal to angle F. So angle B is equal to angle F. And again, I write my reason as given. So now, because we have two pair of angles that are equal, we do not need to calculate the third angle. All right. So if we had a scenario where we had 20 degrees and 60 degrees, and we had 20 degrees and D 100 degrees, then we will need to calculate the ungiven or the unknown angle in the triangle. But now we don't have to, because you know that from similarity, I only need to prove that two of the three angles are equal. Because now I can go and say, well, angle C will be equal to angle D. And my reason will be, it's the third angle in the triangle. So please look at how I indicate my angle and how I indicate it's from a triangle. You can even write interior angles of a triangle if you'd like. So therefore we can say that triangle ABC will be similar to triangle EFD, and our reason will be angle. So that's all they ask you to prove, and we've proven that. But now I want to go a step further and just to show you how to get the correct ratios from two similar triangles. My reason being is that the more you do it, the easier it gets. So it's one more repetition than that you've already done. So what you need to understand is the following. When we work with getting the ratio from the triangles that we proved similar, the order in which we wrote it is very important. Okay? So if angle A is equal to angle E, if A is first, then angle E has to be first in the second triangle. I can't say A and then D, because then when we do the ratios will not work out. So the order is very, very important. So I start with the first two sides. So AB divided by the first two will be EF. That will be how you determine the corresponding side on the triangles. Then we go and we say the last two, meaning BC, divided by the last two FD, which will be equal to, and then to get the last ratio, I use the first and the last, so A and C, so AC divided by ED. So there you have the correct proportions from similarity. Okay, so you will see you need to be very certain of whether you're using similarity or later whether you're using proportion, because the way in which you write the ratios are different. So let's go to example 2. So example 2, they ask us, prove that triangle ABC is similar to triangle DEF. Okay. So again, we first have to look at what's given. All right. So at this stage, you will see that we do not have the sizes of the angles, but we have the lengths of the different sides. So therefore, I will know that I have to use the ratio to prove similarity. So now the biggest question normally is, but which sides do I have to use? Because now the first thing is you can start and you can play the guessing game, okay? And you can say, well, all right, so 3 and 6 will go together because 6 is 2 times 3 and 4 and 8 will go together. But maybe you don't see that. And then you have to go by trial and error. So now you have to use, for instance, you use 3 and 10 and 5 and 6, and then you get confused. So what I would like to show you is that always work from the part that they said, well, now you must prove that those triangles are similar. Meaning, look at the specific order in which they ask the question. Because now, if the examiner did the order incorrect, then you will have a problem in your calculations. But if your order is correct, then you will see you will get the correct ratios. All right. So always first start and work from the question that was given. All right. So as I said, we work with the first. All right. So we work with the first two, so AB and DE. Okay. Then we go and we say, well, then we work with the last two, BC and EF, and then we said we work with the first and the last, the first and the last. All right. So let's go and write it up so that we can see how we do this. So let's start with AB divided by DE. And so you will see that AB's length is given as 5 and DE's length is given as 10. So you'll get a ratio as half, or 1/2, meaning the ratio will be 1 to 2. Then the next one we look at is the last two. So we have BC divided by EF. So now look on my sketches that BC is given as 3 and EF is given as 6, and we get that ratio is also a half. Then we do the last one and we do A and C divided by D and F. So AC has a length of 4 centimeters and DF has a length of 8 centimeters, and you get a half. So now what you will need to see is that these three fractions are the same, meaning the ratios then would be the same. Therefore, you can do the comparison and say, well, AB divided by DE is equal to BC divided by EF will be equal to AC divided by DF. And now you can go and you write and you say, well, therefore, triangle ABC is similar to triangle DEF. And your reason there that you write is sides in proportion. So then you have calculated and you have showed that ABC is similar to DEF. So there's two methods of proving similarity. One, you prove that three pairs of corresponding angles are equal, or you prove that the sides are in the same ratio or same proportion. So after now that we've done similarity, let's look at proportion, okay, because this is where we want to get out today. So the proportionality theorem states the following. The triangle proportionality theorem states that a line drawn parallel to one side of a triangle divides the other two sides of the triangle proportionally. So now this is where the difference comes in between similarity and proportionality. All right. So obviously now you can see that the side TU is the line that divides the sides of the triangle, meaning you must understand that we start with a big triangle, RQS. And then we draw the line TU, all right, and you know that that has to be parallel to QS, okay? So now when it's parallel, it will divide the sides proportionally, all right? So now you have to understand which sides will be divided, because now remember with similarity, we had three ratios, okay? But now, if you look at the diagram, you will see the following. TQ cuts side RQ and TU cuts side RS, meaning it only cuts two of the three sides. Therefore, only two of the three sides can be divided proportionally. All right, so this is very, very important. So now if we go and we want to write which sides will be proportional, then we will do the following. So I will take the top part of the side, RT, it will be divided by the small part at the bottom, meaning the remainder part, TQ. That will be equal to. So then I look at the top part of the side that's left after it's been cut by the line. So it's RU. And then it's cut or divided by the smaller part that's left is US. So now I hope you can see the difference between similarity and proportionality. So with similarity, there are three pairs of sides that are divided into the same ratio. All right. Now with proportionality, only two of the sides are divided into proportion with respect to each other. All right. Now the other thing is with similarity, we use two different triangles, all right, and we use the full length of both triangles as sides, all right. But when we get to proportion, I also basically then, it looks like we have two triangles, but now you must think of it as one triangle being cut by a line parallel to one side of the triangle, and then the two sides are divided. So I use only a section of the one side, and with a bit that's left over, with the section of the other side with a bit that's left over. But now here's the important part. If we did and we say that RT, so the longer side, the longer section divided by the shorter section. If you go to the second part, to get the proportion, now if I do this, now I say US divided by RU. So now what I did is I used the smaller part at the numerator. So now this will not be equal. Okay. So again, the order in which you write this is very, very important. All right. You are allowed to do the following. You can start with a smaller section. You don't have to start with the longer one. So you can do, and you can say, well, then TQ divided by RT will be equal to US divided by RU. Right. The order is important. If I use the small section at my numerator and the bigger section at my denominator, for the second side, I have to do the same. Okay. So let's look at the converse of the triangle proportionality theorem. So now they say if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So meaning the first theorem that was given, it was given that the sides are parallel. Now it's given that the sides are in proportion. So I will have the following. So I have that RT divided by TQ will be equal to RU divided by US. Now this will be the part that is given. Okay. How do I know that? Because it says that the line divides two sides of a triangle proportionally. Therefore, what will your conclusion be? Your conclusion will be that TU will have to be parallel to QS. So they can even ask you to prove that two lines are parallel. And then you know that you can use proportionality to prove that two lines will be parallel. So let's have a look at example 3. So they say BC is parallel to DE, meaning the side BC is parallel to DE. Determine the length of AB. Okay. So now the biggest question will be, but do I have to prove something first? Okay. So because of it is given that it is parallel, you can state the proportion immediately. You don't have to try and prove that first they are similar or something like that. So let me indicate to you or show you how I would go about to answer this example. So they ask you to determine the length of AB. So it's very important for you to realize on your sketch that where is the side that you need to calculate. So I like to use a highlighter or a pen just to mark the side that I want to determine, just to get a clearer picture on how we'll go about to do this. All right. So now I see that I need the top section. I've got the small section. On the other side of the triangle, I've got both lengths of those two sections. So therefore you know that I can do proportionality. I don't have to do similarity. So if we write this up now, always start at the numerator with the side that you need to determine. So what I'm going to do is I'm going to say that AB divided by BD will be equal to AC divided by EC. And now again, your reason is very, very important. So please write there proportionality theorem. All right, please don't forget your reasons. Now I go and I start to substitute the sides length. So AB I don't have. This is what I need to calculate. So I have AB divided by BD. has a length of 3 centimeters. AC has a length of 9 centimeters. And then EC has a length of 4 centimeters. And now just check that you can just take out the centimeters. We're not going to use the unit in our calculation. Let me just erase that for you. So we have 9 divided by 4. So now the easiest way to get rid of the 3, so it's an equation basically, so we work with opposite calculations, meaning I divide by 3, so to get rid of the 3 I have to multiply by 3, and the golden rule is do the same on the other side. So this side they will simplify, meaning that AB will have a length of, and now some people will say, but you're smart enough, just quickly calculate it, but that's why I come and say always get your handy calculator, all right, and rather be safe than be sorry, and do the calculation. So you say 9 times 3 and you divide it by 4, and you will see that in simplest form you will have an answer of 27 divided by 4. And now you will have to make sure the instructions in the question, whether they say leave it in simplest third form maybe, leave it as a fraction, or they might indicate you to round to 2 decimal places. All right. In my opinion, if you get to 27 over 4, add centimeters as your unit, and then that will be my final answer. All right. Only if they specify in the specific question to round to 2 decimal or to 1 decimal place, then you can go and you can do the rounding. Okay. But then again, if you were to round and you were to say, well, this will give an answer of 6,75 centimeters, then if it is being marked, then you will still get full marks. They will not penalize you for that, unless the instruction states to leave it in simplest form or then in a fraction. Okay, so again, please make sure of the instruction for that specific question. So let's look at example 4, and we see that they give you that BC is parallel to DE. Determine the length of EC. All right, so EC is the small little section at the bottom. Round off your answer correct to 1 decimal value. Okay, so again, because they show you there's parallel sides, then you will always try and do proportionality first. All right, so to see which side we need or which length we need and ECs, I will always write that at the top. It only simplifies my calculations later. Otherwise now I have to understand, do I have to invert my fractions on both sides? How do I multiply? Then it gets a bit more complicated. Then the chance of making a mistake is better. All right, so I want to always try and keep it as simple as possible. Therefore, whatever I need to calculate, I put as my numerator. So I start with EC divided by AC is equal to, and then now remember the small or the shorter section, so BD divided by AB. And again, please write there proportionality theorem. Now I can start and doing my substitution. So I do not know the value for EC. The length of AC is 4. The length of BD is 2. And the length of AB is 3. Now again, I need to get rid of the denominator, so I have to multiply. So we multiply by 4, and we do both sides, so that the left-hand side will simplify. And now I take my calculator again, and I say 2 divided by 3, multiply by 4, and it gives me a value of 2,666. And now again, please look at your instruction. It says correct to 1 decimal value. So now, if we go to 1 decimal value, we know that that should be the answer, meaning that the second decimal will be the determining factor whether I will round up or whether I would leave as is. So in this case, the second decimal is 6, it's greater than 5. So if I round this correctly, it will be 2,7. And again, the unit is given, so please add the unit as centimeters. Okay. All right, so now we've done similarity, we've done proportion. Now I want to show you another rule that we use when lines are parallel in a triangle, and that's now then called the midpoint theorem. Okay. So with the midpoint theorem, it states the segment joining two sides of a triangle at the midpoints of those sides is parallel to the third side and is half the length of the third side. All right. So this is very, very important. So they have to indicate to you that you are using the midpoint of a side of a triangle. Whether they indicate to you as given with maybe indicating one stripe and two stripes, or they can give you, say, AD is 3, DB is 3. So there's a lot of ways of indicating that it's the midpoint of a line. Okay. So what will my conclusion be? So if we look at this, it states that the line drawn through the midpoint of the one side and through the midpoint of the second side will be parallel to the third side. Okay. And now they also say that it's half the length of the third side, meaning that when we work, so let's write this out. So we say, well, then our conclusion will be that DE will be parallel to BC. All right. And then the next part of my conclusion is that the line that was drawn, meaning DE, will be half of the third side. And then BC is the third side, so it's half BC. All right. So you must please look at that as well. So now I'm giving you a third method where you can calculate the length of a side, because now you might be using the midpoint theorem. Okay. So we've got similarity, we've got proportionality, and now we've got the midpoint. So if you look at the first example on the midpoint theorem, it states complete the following. Now, you must please remember, and when you go through previous exam papers, you will see that when you get to the Euclidean geometry section, question 7, 8, and 9, you will see that they will always start the very first question to be complete the following, so that the statement is true, or just complete the following. Okay. And now, when you've completed that theorem, that will 99% of the times be the theorem that you will be using to solve the next questions. Okay. So now they ask you the segment joining two sides of a triangle at the midpoints of those sides is, so now I need to write something there, to the third side and is half the length of the third side. So meaning now that you must remember that you need to study your theory, and so now you can write there, well, it will be parallel. So you will see that in the exams you only need to write parallel. You don't need to copy the whole sentence and include that part. You can just write the part that is missing. Okay. So you write they are parallel. Then if you go to the next question now, you will see they ask you to determine the length of x. Okay. So now what I did is I included again the same sketch as the previous one, but now in the example 5.1, they didn't need to give you a sketch. All right. You just need to know the theory. So determine the length of x, so we see where x is given, and now we must look what else is given. All right. So please realize that when they give you a marking on that side and that side that are the same, meaning those two parts are of equal length, meaning this is the midpoint of that side of the triangle. If you go to the second side again, you will see the marking on this section and the marking on that section is the same. So meaning that that again will be the midpoint. Meaning now you've got a line passing through the midpoints of two of the sides of the triangle. So now what will your conclusion be? So I know that that side is parallel to that side. And I know that that shorter side is half the length of x. But now I just need to ask yourself, what do they ask you to prove? Or what do they ask you to calculate? So do I need to really state that those two sides are parallel? No, because I don't need it. Okay. So the only thing that I'm going to do is I'm going to start writing, and I'm going to say that the 8 centimeters will be equal half of x, because it's the half of the third side of the triangle. And now your reason will be the midpoint theorem. But if you don't write the midpoint theorem, you will be losing marks. All right. So please remember, with Euclidean geometry, when you do a statement, also supply your reason. Obviously, unless the question states without giving reasons. All right. So now, there's a lot of ways of calculating that, but I always like to stick to one method if possible. So I need to get rid of the half, so it's a fraction. So to get rid of a half, I have to multiply by 2. So I have to do it the same on the left-hand side. I have to multiply by 2. So therefore, you get that x has a length of 16. And again, I put the unit centimeters. Why do I put the unit? Because on the diagram that was given to you, it's given as 8 centimeters. If it was only given as 8, then you will write this as 16 units. So now some might argue and say, but units is not important. So where units do count is when you work with area and volume. All right. But now get into the rhythm of always using the correct units when units were given. So let's look at example 6. So now they ask you, determine if MN is parallel to GH. So what would be the difference between determine and prove? All right. So if they ask you to prove something, then you know it's true. You just need to show why. All right. If they say determine, then it can go either way. All right. So what would make MN parallel to GH? So remember, with proportionality, if the line is parallel to the base, all right, then it divides the sides into proportion. Or if the line passes through the midpoint of both the sides. So now we must be careful, because now we see PM is 56, MG is 21. So now it's not the midpoint. PN is 48 and NH is 16, so it's not the midpoint. But be careful now to just say, well, no, it's definitely not parallel because it's not through the midpoint. All right, so remember, there's other reasons for lines to be parallel as well. So let's try and use proportion. So I start with PM divided by MG, and I have 56 divided by 21. Now what I would like to say is take your calculator and you calculate 56 divided by 21 and see if this will be simplified, and you will get an answer of 8 divided by 3. So now I will go to the opposite side and I will say, well, now I have PN divided by NH. So I have 48 divided by 16. So again, 48 divided by 16 on my calculator gives me a value of 3. So your conclusion is that the ratio PM divided by MG is not equal to PN divided by NH. So therefore, MN is not parallel 2GH. So that is very important for you to make that conclusion at the end. All right. So please, this could have been equal, but now you would have said, well, they are not parallel because it's not through the midpoints. All right. So please make sure that you look at all the different possibilities for that specific question. Example 7. Look at the right-angled triangle. Determine the length of y, and then in B, determine the length of x. So if we look at y in A, then we will see that because it's a right-angled triangle, then hopefully you already started screaming that you must use the theorem of Pythagoras. All right. So because I've got the two right-angled sides as length. All right. So for A, I can say that y squared will be equal to 8 squared plus 6 squared, and your reason will be Pythagoras. So y squared will be equal to, so now this will give a value of 100. I need to simplify, so I get rid of the square by using the square root, and therefore I get y is a value of 10, and then again my unit as centimeters. Okay. Now I just want to comment on something. When we work with trigonometry and we work in a specific Cartesian plane, we've got a positive x-axis and negative x-axis, a positive y-axis and negative y-axis. Therefore, when we do the same calculation there and we take the square root of y squared, then you will remember that you would have been taught that you would have the following. That y will be equal to plus minus 10. Okay. Meaning that it shows position. All right. So if you have a Cartesian plane and I would use plus 10, it will be on the positive y-axis, and if I use minus 10, it would be in the negative axis. All right. Meaning that you might have had a triangle maybe that was in the third quadrant. But because now with Euclidean geometry, we're not working in a set of axes or on a Cartesian plane, all right? We don't care about direction, or we don't care about position. We want size only, all right? That's why I do not worry about the plus minus, all right? Then if you look at B, they ask you to determine the length of x. All right. But now you can say, but I used Pythagoras in A. Why can't I use Pythagoras again? Because if you look in the smaller triangle where we have the side x, there's no other lengths given. All right. But what you will notice is that it is given that the line x passes through the midpoints of both the other two sides. So automatically you will think, oh, midpoint theorem. All right. So therefore, I know that the line passing through the two midpoints will be half the length of the third side, meaning that x will be equal the half of y, and your reason will be midpoint theorem. So x will be the half of 10, meaning it will be equal to 5 centimeters. Okay. So please, when you get a diagram, make sure whether you're going to use similarity, proportionality, or the midpoint rule, or the midpoint theorem. So let's have a look at example 8. So they say determine the length of DE. All right, so let's look at where we have DE. Okay. If it is given that triangle ADE is similar to ABC. So therefore, we don't have to prove similarity. So now please be careful that you don't get confused with proportionality, all right, and use proportion. Why do I say that? I indicated to you when we use proportion, we work with two sides. Similarity, we work with three sides. So with proportion, the sides that are parallel, we don't use their lengths, meaning I wouldn't have used BC because now you see that BC will be parallel to DE because of the angle of 90 degrees. Okay, so therefore I will always start using similarity because they've given me that these two triangles are similar. So now I start with my correct ratios. So I will say that AD divided by AB will be equal to DE divided by BC will be equal to AE divided by AC. All right. And there you can write similarity. Or you can write similar triangles. Same reason. Okay. So now I start to do my substitution. So AD has a length of 20. It has been given to me. AB has a length of 24. DE, we do not have a length for DE. BC has a length of 18. Then we have AE, we do not have a length for AE, and we do not have a length for AC. All right. But now you will see there are three fractions or three ratios. And you must understand that you can always only work with one equation at a time, so only two of them. So I will always use the one which I have the numerator as well as the denominator, 20 divided by 24. And then I use, well, the second one will be where I have at least one known and one unknown, meaning I don't know DE, I know 18. Therefore, 20 divided by 24 will be equal to DE divided by 18. So I need to calculate the value for DE. I need to get rid of my denominator, so I multiply by 18. I multiply by 18. So therefore I know that will simplify. So I will get a value for DE as, and again, I take my calculator, I say 20 divided by 24 multiplied by 18. And I get a value of 15. And now no units were given. So what I then would like to do is I like to add the units. All right. So I hope you understand how I used similarity to calculate the length of DE. So let's look at example 9. So they say determine the length of x, okay? And now I have to look at where it is given that we have x. So I've got two parallel sides. So always see that first, parallel sides. So now you might be thinking proportionality, okay? But if you look at where the x and the other length of the sides are given, you will see that x is one of the parallel sides and one of the other sides that's given is also the parallel side. Therefore, you know you cannot use proportion, all right? Because when you calculate with proportionality, all right, the proportion ratios, we only use the two sides that are being divided by the parallel line, all right? Meaning, I work with these two. Let me mark them for you. Meaning, with proportion, I work with that side and I work with that side. All right? Because those are the sides that are being divided proportionally from that parallel line, which is parallel to the third side of the triangle. Okay. So therefore, I cannot use my calculations with that. So therefore, I need to know that I need to go to similarity. Okay. So therefore, similarity, I need the full length of the triangle. So 2 plus 6 will give me a length of 8. All right. So now, again, I always start with what I need to calculate as my numerator. So I need to calculate x. So I have x at my numerator. All right. So now I need to determine the corresponding side for x, which would be the other parallel side, which is 6. So it's being divided by 6. And now you just need to understand that the x will be shorter than 6. So when I work with the corresponding sides from the side of the triangle, I need to start with the shorter side, which is 6. So I have 6 divided by, and then I calculated the length of the side is 8. So then I divide by 8. Now again, I need to simplify. So I multiply with 6. I multiply with 6. So that I can get a value for x. So if I take my calculator, 6 times 6 divided by 8 will give me a value of 9/2. And then again, my advice is to leave it as 9/2 centimeters. But now you can argue and say, but if you measure something, we don't say it's 9/2. So you can go and say, well, it's 4.5, so it's 4.5 centimeters. Okay, so I hope you understand the difference when I'm using similarity, when I'm using proportionality, and then when I'm using my midpoint theorem. So let's look at example 10. So what I find is that when learners are given a ratio, they do not understand the meaning or how to indicate that specific ratio to a diagram. All right. So firstly, please realize that when we work with a specific ratio, okay, it's just that the ratio. It's not necessarily the length of a side. All right. So let me show you what I mean. When we look at the diagram that was given to us, they say in triangle MOR, meaning the bigger triangle, we have MO parallel to NS, so it's indicated with the arrows, and then ST is parallel to ON. Now they give us that RS to SO, meaning the ratio of RS to SO, RS to SO is equal to 3 to 2, meaning that RS divided by SO is equal to 3 divided by 2. So now if you look on the diagram itself, then I look at RS and I now see, but wait, I want to do this and say RS is 3 and I want to say SO is 2. Okay. But now the common mistake is that now you automatically assume that that is the length of the side. All right, and that's not necessarily true, okay, because they were given the ratio. So please remember that we work with the ratio, okay. So now they say determine A, the length of RT, all right. So now I need to look at where I have RT. So what you could do is, if I can give you a tip, is to go and draw yourself a little triangle, all right. So now, will I use RM? No, because it don't know nothing about MN. All right, so I'm going to draw a triangle. So I've got R, I've got N, and I've got O. But the question states that determine the length of RT. So now what I'm going to do is I have to include the point T. So I have ST, because now I know that this side is given to be parallel to that side. And now I can go and indicate the values that was given. NT is given as 6, and then that ratio was given as 3 to 2. Now it looks a bit easier because now I only work with a diagram in which I have the length of TR, or the side of TR. Because now if you look at the full diagram, then you might get confused as to where I'm working with. Okay. So now you understand. I have parallel sides, so I want to try to do proportion. So I want to calculate the length of TR. So I will start with it first. So TR divided by NT must be equal to SR divided by OS. So again, they are equal in a ratio. Okay. So I have TR divided by 6 is equal to 3 divided by 2. So I need to get rid of the 6 at my denominator, so I multiply by 6. I multiply by 6. And again, what I do is I take my calculator because I want to cancel out any possible mistakes. 3 times 6 is 18 divided by 2 will give you then a value of 9 centimeters. All right. Then we can go on to B. So B, they say, determine the length of MN. So let's go and we can say, well, now I've determined that that is 9. Because now they want you to calculate the length. So what I'm going to do is I'm going to take a highlighter and I'm going to highlight MN. Okay, because that now is the side that I need to calculate. So again, what you could do is you could go and you can redraw yourself the diagram in order to make it a bit easier for yourself, all right? Or you can keep as is, and you will see that now I have, again, 2 parallel sides in MO and NS. So you know that the parallel sides will divide the 2 other sides of the triangle in the same proportion or in the same ratio, correct? So now you must realize that I can determine the length of NR because I know NT is 6 and TR is 9. So if I add 6 and 9 together, it will give me a length of 15 centimeters. And I've still got the same ratio for RS and SO that I can use. So now I start with the side that I need to calculate, meaning MN. So MN divided by OS must be equal to NR divided by SR. All right? And you can write the proportionality theorem. So I need to calculate MN. The length of OS is 2. The length of NR is 15. And the length of SR is 3. So now again, I multiply by 2. I multiply by 2. So I need to simplify because I need to calculate the length of MN. So again, I take my calculator, so I say 15 divided by 3 multiplied by 2 will give me a length of 10 centimeters. Okay. So I really do hope that you understand that how I used the ratio to calculate the remainder or the unknown sides. All right. And just again, I want to emphasize that it's the ratio, it's not the given length. All right, so that's very, very important. I'm going to skip example 11 for now, and I want to get to example 12. So, in the diagram, OK is parallel to PA, and GK is parallel to AD. Now they give you that LA is equal to 6 centimeters. So take a pencil, take a color pen, and indicate that LA is 6 centimeters. All right. So what I'm going to do is I'm going to just circle that so you know that that is an actual length that is given. All right. So then I'm going to look at LK divided by KA is equal to 2. So this will be then the same that if I say, well, it is 2 divided by 1, meaning the ratio of LK to KA will be equal to 2 to 1. So I look, where is LK? I write the 2, and KA, I write the 1. So you will now see that because I've encircled the 6, that's an actual length, okay, that I've given. And then the 2 and the 1 will be then the ratio. Now they ask us to determine the ratio of LT to GD and give reasons for your answer. So now they want LT to GD. So they're skipping TG. All right. So this gets a bit more difficult. So now you need to understand that because there are two sets of parallel lines, I'm going to see if I can use two sets of triangles. So let me draw them for you so that you can see what I mean. So the first is triangle LGA, okay? And then we know that there's a line TK that is parallel to the base. That's in the ratio 2 to 1, and I know that that has a length of 6. Okay. Then we go, and then the next triangle will be LDA, and then you've got a line there, GK, that is parallel to DA. And again, this is the ratio 2 to 1, and this is to the ratio of 6. Okay. So now you need to understand that in the one triangle, I can determine LT, and in the second triangle, I can determine GD. And then what I can do is then I can use that then to get to LT to GD. Okay. So that will then be the easiest way to solve this question. All right. And then if you go to the next one, to B, you have GK divided by DA. Okay. So GK divided by DA. So again, now you must understand that those are the parallel lines. So now I have to move to similarity to prove that. Okay, so I start with proportionality. Now I go through to similarity. Okay, and then the value of LD times TG, if TG is equal to 2 centimeters. So again, they've given you now TG is 2. Then you can use what you've proven with your previous ratios. You can multiply LD times TG because you will be able to determine a length of LD, okay? And then after you've determined that length, then you can multiply by 2, and then you will get your answer. So I hope I could have helped today to get you to a better understanding on similarity and proportionality. All right, and then please don't hesitate to work out extra examples. All right, go to previous exam papers and do as many questions as possible. Then I just again would like to thank future managers for them allowing me to use diagrams from the grade 12 textbook and then some inspiration. Push yourself, all right, because no one else is going to do it for you. I repeat it, push yourself, because no one else is going to do it for you. You determine your future, work hard, and you will prosper. Good luck.